You're welcome to this channel once again. This is Dr. Fred Academy. In this video today, we shall be looking at the osteology of the thoracic limb. Okay, that is the bones, the study of the bones that forms the thoracic limb. Remember that in my previous video, we talked about the bones that formed the thoracic limb girdle. Okay, remember that the thoracic limb is entirely attached, is attached to the trunk of the animal, okay, by the help of the thoracic limb girdle. Okay, the entire forelimb of an animal is attached to the trunk, is attached to the body of the animal with the help of the thoracic limb girdle. And this thoracic limb girdle is made up of three bones. Okay, these three bones includes the scapula, the clavicle, and the coracoid. The scapula, the clavicle, and the coracoid. The thoracic limb girdle is also called the shoulder girdle, okay, or the forelimb girdle. Since I talked about this in my previous video, if you want to go back to it, if you want to watch the video or listen to it before this very one, this is a link to it, so you can copy out this link. Okay, I hope I remember to paste this also, the link, on the comment section, so that you can click on it or copy it out and paste on any good browser, so you can watch the video on YouTube as well. Okay, so in today's video, I won't be going back to the scapula, clavicle, and coracoid. I will be dwelling on the entire forelimb. I will be studying the forelimb proximo-distally. Now, what I mean is from the bone, or from the parts that are closer to the body to the parts that are away from the body. So we'll be starting from the arm, that is the upper arm or brachium. Okay, the bone that forms that portion of the skeleton is called the humerus. Now the bones that form the antebrachium, the forearm, they are called the radius and the ulna, two bones there. And we also have the carpal bones, which forms the carpus. We also have the metacarpal bones, which forms the metacarpus. And then we have the final points, the bones of the digits, which are called phalanges. They are called phalanges. Bones of the. So at the end of this video or discussion, you should be able to understand the parts and parts of these bones and how they appear in different animals. You're welcome once again. Finally, before I move away from this slide, I also want to show you this link. This is the link to the channel Dr. Fred Academy. If you copy out this link and paste on any good browser on YouTube, you can get our entire videos. Let's move. Going back again to what I talked about earlier on, this is what we discussed initially in my previous video. So in this video, we shall be talking about the humerus, the radius, and the ulna, okay, and then the carpal, that's the carpal bones, the metacarpal bones, and then the digits. Okay, this is in human, this is in dog, this is in the pig, this is how it appears in the sheep, and this is how it appears in the horse. Remember that this veterinary anatomy is a comparative anatomy. Okay, so you need to understand the differences that exist among different species, not just a single species. You need to understand different species and the differences in the appearance of these bones in different animals. Okay, so let's start with the arm itself. That's the upper arm, which is the humerus. The upper arm, or brachium, or humerus, or arm, whichever one you want to call, is a long bone. Okay, it is this bone that attaches to the scapula. Okay, so the humerus, like I said, is a long bone. Okay, it's a long bone. It has two epiphyses. Okay, now this is the proximal epiphysis. Okay, and then this is the distal epiphysis. the proximal epiphysis makes contact with the scapula. Okay, now this is the head of the humerus. This is the head. It is this head of the humerus that makes contact with the glenoid cavity of the scapula, okay, forming a joint called the shoulder joint. Okay, anatomically that joint is called scapulohumeral joint. Scapulohumeral joint. Okay, now the distal extremity here is the portion that makes contact with the radius and the ulna. Okay, it is called, so it forms a joint called the elbow joint. Okay, either you call it humeroradial. Of course, they are composite. It is a composite joint actually. When we talk about composite joint, we mean a joint that is formed by more than two bones. Okay, for instance, the radius and the ulna makes contact with this distal epiphysis here. Okay, forming humeroradial joint and then humero-ulnar joint. Now let's leave that. We're not talking about joint in this class. Okay, so so we have the proximal epiphysis and the distal epiphysis, and then this is the diaphysis. Okay, that is the body or the shaft of the humerus. Okay, now what we have is the long bone placed obliquely downward and backward between the shoulder joint, okay, that is the scapulohumeral joint proximally, and the elbow joint distally. It has a shaft and then two extremities. Okay, now let me briefly talk about some of the parts or features of this bone, of this long bone here. We have the head here. Okay, just beneath the head is the neck. Okay, the neck of the bone. Okay, the neck is the portion that connects the head to the epiphysis, to the proximal epiphysis of the bone of the humerus itself. Okay, here we have a greater tuberosity. Okay, we have greater tuberosity here, and then we have lesser tuberosity here. Okay, this is a greater tuberosity. This is also the greater tuberosity here. Okay, because the greater tuberosity is placed laterally. The greater tuberosity is on the same side with the deltoid tuberosity. Okay, so the greater tuberosity is on the same side with the deltoid tuberosity. Okay, so now this greater tuberosity here, this is a greater tuberosity. It is also called the lateral tuberosity. It's also called the lateral tuberosity, while the lesser tuberosity is also called the medial tuberosity. Okay, now this is the deltoid tuberosity. Okay, now around here is also a roughened surface or structure just around on the medial aspect again, just a very little rough but roughened surface. It is also called the teres tuberosity. That's a teres tuberosity. Okay, now at this point we have deep grooves. Okay, we are seeing these deep or twin grooves. Okay, two of them. Okay, they are grooves. Okay, this groove is called the bicipital groove. Okay, it is meant for the passage of the twin tendons of origin of the biceps brachii. Okay, the twin tendons of origin of the biceps brachii muscle. You know, the biceps brachii muscle has two heads. Okay, biceps. Okay, so their tendons of origin passes through these. Each one passes through here. The second one passes through here. Okay, so that's why it is called the bicipital groove. The bicipital groove. Okay, this is the body, like I said earlier on, and then on the lateral side of this humerus is also a little depression, a shallow depression, and it's a little bit curved, giving the bone an italic, S or F shape. Okay, this depression is called the musculospiral groove. Okay, now this musculospiral groove is meant for the lodgement of the brachialis muscle. Okay, that's the brachialis, for the attachment of the brachialis muscle. It is called the musculospiral groove. Now let's look at the distal epiphysis of this bone. The distal epiphysis of the humerus, of course, it has both the cranial and the caudal aspect. Okay, this is the cranial aspect, okay, or the cranial part, while this is a caudal part. That means that this part faces caudally, while this part faces cranially. So if you stand in front of the animal, this is a part you'll be seeing. If you stand at the back of the animal, this is a part you'll be seeing. All right. So let's start from this the caudal surface of this bone. Now, on the caudal surface, you will find out that there is a depression. Okay, or okay, sorry, let's study this structure first. There is a condyle. Now, this is a smooth surface for articulation with the radius and the ulna. Okay, this now we have a bigger one here and we have a smaller one here. Now, this smaller one here is called the lateral condyle. It can also be called the capitulum, the lateral condyle or the capitulum. We have the medial condyle here, which is also called the trochlea. It's called the trochlea. Okay, so now let's go back. Now, looking at this cranial part. Now, looking at the top of this condyle, just above the condyle at this point, we have a shallow depression. Okay, it's a shallow depression. Actually, the bone that lodges there is the radius. Okay, so it is called the coronoid fossa, or you call it the radial fossa. Okay, it's called the coronoid or the radial fossa. Now, when you look at the caudal aspect of this bone, there is a deeper opening or depression. Okay, at this point. Now, when the bone, when the elbow is extended, the anconal process, you get to see the anconal process. It belongs to the ulnar bone. The anconal process is part of the ulnar bone. It lodges into this place. Okay, and that part of the ulnar bone that enters here is called the olecranon bone. We'll get to see that when we get to the forearm. Okay, so that bone is called, or this depression now is called the olecranon fossa. Okay, the olecranon fossa. Okay, so this olecranon fossa allows for the lodgement of the anconal process of the olecranon bone, which is also part of the ulnar bone. Okay, at both the lateral and the medial parts of the condyle, we have what we call the epicondyle. This is an epicondyle, this is the lateral epicondyle. Around here, we also have the medial epicondyle. Now, this is just a short story about or description about the humerus. Okay, we have the proximal extremity, we have the shaft, and we have the distal extremity. So this page explains further on the proximal extremity. You say the bone consists of a head, neck, and two tuberosities, that's the greater and lesser tuberosities. Okay, and the intertuberal or bicipital groove, which I told you earlier on. The head presents a circular articular surface. Now, this is a circular articular surface which articulates with the glenoid cavity of the scapula. Okay, we also have the greater tuberosity, which I talked about earlier on. Okay, and we also have the lesser tuberosity. Then finally, we have the intertuberal groove, okay, which is bounded by the anterior divisions, okay, of the two tuberosities. The anterior divisions of the two tuberosities. Okay, the intertuberal or bicipital groove is bounded by the lesser tuberosity and the greater tuberosities. Okay, and said in real life, it is covered by a fibrocartilage to give passage to the tendon of origin of the biceps brachii. Now let's look at this is the shaft. Okay, the shaft, that's the body. It is twisted. Okay, it has a twisted appearance. Okay, and has four surfaces. That's the cranial surface, the caudal surface, the lateral surface, and then the medial surface. Okay. Now the lateral surface is spirally curved and forming the musculospiral groove. Okay, I already talked about all that. Okay, so you can take your time to read more and study the shaft of this bone. Now let's look at the distal. The distal extremity is here. Okay, this is the distal extremity. It is an oblique surface which is divided by a ridge into two condyles, the medial and lateral humeral condyles. These are already explained earlier on. The medial being the larger, of course, this is the larger, and then the medial condyle is crossed by a groove which extends into the olecranon fossa, okay, into the olecranon fossa and articulates with the semilunar notch of the ulna. Okay, now this extremity presents cranially above the articular area, the coronoid fossa. This is a coronoid fossa, which receives the coronoid process of the radius in extreme flexion of the elbow joint. All right, and then the caudally and above the condyles are two thick ridges, the epicondyles. The epicondyles, just by the side, I talked about it on the other slide. The medial epicondyle is more prominent and furnishes origin to flexion muscles of the carpus and digits, and bears a tubercle for attachment of medial ligament of the elbow joint. The margins of the olecranon fossa are for the origin of anconeus. The lateral epicondyle bears laterally the condyloid crest in the form of raised ridge, which gives origin to extensor carpi radialis muscle. Between these two epicondyles is the deep olecranon fossa. This is a deep olecranon fossa, which receives the anconeus process of the ulna during extreme extension. The distal extremity also presents a rough depression laterally and a tubercle medially for a collateral ligament of the elbow joint. Okay, let's look at that of the cat and dog. This is the dog, because there are certain features that are that are specific to the dog and the cat at the distal extremity or the distal epiphysis of the humerus. Now, if you look at that of the horse, starting from the horse, the floor of the olecranon fossa, as we saw in the horse, was not perforated or is not perforated. Okay, is not perforated. There's no opening there. But the floor of the olecranon process in the dog is perforated, is open, so that you can go through the caudal aspect. You can put an object through the caudal aspect and it will come out through the cranial aspect of this distal extremity of the ulna. Okay, now that opening is called the supratrochlear foramen. Supratrochlear foramen. Okay, so the supratrochlear foramen, is an opening on the floor of the olecranon fossa, okay, which enables passage of vessels, through that point. Now, let's look at that of the cat. Okay, in the cat, we also have an opening, but not on the olecranon fossa this time, but at the side, at the mediodistal part. Okay, this is the medial part of the bone. Okay, that's why it's called the mediodistal part of this bone. We also have an opening here, okay, just above the medial condyle, okay, and that opening is called the supracondylar foramen. Supracondylar foramen. It gives passage to the median nerve and brachial artery. It gives passage to the median nerve and brachial artery. So you can see the species variation that exists between the humerus of the horse, that of the dog, that of the cat, and also you get to see the differences that exist even amongst the other species. This is that of the sheep and goats. Okay, these are their features. Okay, features. Now this is the features of the humerus of the horse. These are the features. This is that of the pig. Okay, now some of these things are just little differences that exist or that are peculiar to these species, the humerus of these species. So we have the sheep and goat, we have the horse, we have the pig, the dog here, we have the rabbit, we have the fowl, that's a chicken, okay, or the bird. All right, let's look at just a picture to show you more of the parts of these bones. Okay, the major or the greater tuberosity. This is the head. This is the articular surface of the head. This is the neck. All right. This is the shaft. Okay. This is the distal extremity. The distal extremity or the distal epiphysis. Okay. Here you have the olecranon fossa at the caudal aspect, the radial or coronoid fossa on the cranial aspect. You have the trochlear, we have the capitulum. We also have the epicondyles, okay, the lateral epicondyle and the medial epicondyle. All right, this is the articular surface, that is at this point now, the surface here, okay, the articular surface of the condyle, okay, of the distal epiphysis. This is the surface that articulates with the radius and the ulna. Now, having talked about the entire arm or humerus, let's talk about the forearm, the osteology of the forearm or the antebrachium. Now, the bones that form the antebrachium includes the radius and the ulna. This is the radius, this is the ulna. This is a typical structure of the antebrachium in man, in humans, okay? Between the radius and the ulna, or the radius and ulna is held, they are held, together by a ligament called the interosseous ligament. The interosseous ligament, okay? This ligament is not very tight and it allows for, rotation of the radius on the ulna, okay? That's why the radius, you can twist your hands, or the animal can twist the forelimb or the antebrachium. Okay, the radius rotating over the ulna and yet held in place. All right. So this now shows you that in humans, okay, you can twist your hand, opening your palm. That is supination. That process is called supination. The radius and ulna are parallel. Okay, they are parallel when you put your hands in a supine position. In a supine position, that is supination. Okay, while in a prone position or in pronation, the radius rotates over the ulna. Okay, the radius rotates over the ulna in a prone position. Sorry, in a prone position or pronation, the radius rotates or becomes on top of the ulna. So this is supination, this is pronation. Okay, just to use this to explain to you what happens in animal, since this is what you should or you may be more familiar with. We also have a neutral position. So this is the supine position, supination. Now this is the prone position, pronation, while this is the neutral position. Okay, let me show you the elbow joint. That is the joint between the humerus and the radius and ulna. Okay, this is the humerus, the distal part of the humerus, while this is the radius and the ulna. This is the humerus, this is the radius. Okay, this is the ulna, this is the ulna. Okay, the radius and the ulna. So this is a composite joint. Okay, the joint formed here between the humerus and the ulna is called humero-ulnar joint. Then between the humerus and the radius is called humeroradial joint. And then between the radius and the ulna is called the radio-ulnar joint. Okay, so you have about 3 joints at this point. So this is the point of elbow. This is it here, the elbow joint. Okay, so having talked about the humerus, let's talk about the radius and the ulna. This is the radius and the ulna in the dog. This radius and the ulna in ruminant. This radius and the ulna in horse. Okay, now let's look at these parts or bones critically. In the dog, that's in carnivores, the radius and the ulna are almost of equal size. That is in width, thickness. Okay, but the ulna is slightly longer. Okay, because of the presence of the olecranon bone. This is the olecranon bone. This projection above the radius or above the radial part, okay, from here upwards is the olecranon bone. Same thing here, the olecranon bone, the olecranon bone, and this projection here, this projection, that is the olecranon. It is actually a thickness, all right? A thickness is an enlargement. It's called the olecranon tuba. Olecranon tuba. Then the projection on the tuba is called the point of elbow. Okay, the point of elbow. Okay, so this is the olecranon tuba. This is the body of the olecranon. The body of the olecranon. The body of the olecranon. Okay, now this C-shaped part is called the semilunar notch. Okay, we'll get to see that clearer or clearly more in other pictures or slides. So you see in the dog, the radius and the ulna are almost of equal size. Now look at the space between them. That is the interosseous space that is occupied by the interosseous ligament. Okay, so in the dog we have just one but large interosseous space. It's only one interosseous space and it's also very large. Okay, it's interosseous, occupied by the interosseous ligament. Now let's look at that of the ruminant. The ruminants have 2 interosseous spaces. That's a proximal interosseous space, this here, and there's also another one here, though not very clear on this slide. Okay, there's another one here. So we have a proximal interosseous space and a distal interosseous space. Look at the radius. The radius is far much more larger than the ulna. Okay, this is the radius. Okay, and then this is the ulna. But you can see that the thickness, the radius is far much more thicker than the ulna. And then in both the ruminant and dog, the radius and the ulna, or the ulna, reaches or occupies the entire, extends the entire length of the radius. Okay, you see the ulna. Same thing with the ruminant. You see the ulna. Okay, it reaches the entire length of the radius. Now, when you come to the horse, okay, that is the equine species, whether horse or donkey, you find out that the ulna, you see the radius is very large, but the ulna here, it didn't extend to the distal portion of the radius. Okay, it stopped about 2/3 the length of the radius. You see the ulna extends about 2/3 up to about this point, the length of the radius. So it didn't get, the ulna here didn't get to the distal extremity of the radius. That is in equine species, and it has only one interosseous space. That's the interosseous, which is occupied by the interosseous ligament. Okay, let's move on. Let's move on. You can watch a video on this, the radius and the ulna, okay, using this link here, using the link below. Okay, this link I will also paste on the comment section. All right, so you can click on it and watch further videos. Now, this is the ulna of the dog, and the radius is separated now. Okay, you can see the different parts of these bones. Okay, you have the olecranon bone. Okay, you have the anconil process, which is a projection. Okay, a projection of the olecranon. Okay, we'll see more pictures, clearer pictures. And this is a semilunar notch. This is a coronoid process. Nutrient foramen. Okay, this is the interosseous crests. Okay, this is articular circumference. While this is a styloid process. the ulna. Okay. We also have the radius here. Okay. So the radius also have its own parts. Okay. This is a capitular depression. Okay, the point of articulation or the point that attaches to the humeral condyle. Okay, that is a capitular depression. Okay, that attaches to the capitulum of the humerus. Remember, the capitulum is on the distal extremity, or is part of the condyle. Okay, which is at the distal extremity of the humerus. We also have the neck here. Okay, articular circumference. We have the radial tuberosity. Okay, you have the nutrient foramen, just like you have in the ulna. Okay, where nutrient is supplied to the through which nutrient is supplied to the bones. Okay, you have the lateral border and the medial border, interosseous crest. Okay, the volar surface, and here we have the ulnar notch. Okay, is the point where the ulna articulates with the ridges, and then you also have the styloid process, just like you have in the ulna. So let's see clearer real life. Okay, this is the equine species. Okay, see the ulna stopping about 2/3 the entire length of the radius. Okay, and the radius is very large. See the single interosseous space. This is the bovine. See the proximal interosseous space. See the distal interosseous space. Okay, that's in bovine species, proximal and distal interosseous space. Now, same thing happens in the porcine, that is in the pigs. You have the proximal interosseous space, distal interosseous space. Now, let me talk about the radius and ulna of pig. Now, in our domestic animals, it is in the pigs that you have the ulna, okay, being larger than the radius. Unlike in other species, in others, the radius is always larger. Radius larger than the ulna in equine, in bovine or ruminant, radius larger than the ulna, radius larger than the ulna. But in the porcine, in pigs, and then in birds, in pigs and in birds, you have the ulna being larger than the radius. Okay, this is the semilunar notch. Semilunar notch. This is semilunar notch. Semilunar notch. Semilunar notch. Okay, and then this is the anconyle process. The anconyle process is the projection that enters into the olecranon fossa. You remember the olecranon fossa is in the humerus. That's the caudal aspect of the distal extremity of the humerus. So in extreme extension of the elbow joint, the anconyle process enters into the olecranon. Okay, so like I said, in extreme extension, when the elbow joint is extended, this anconyle process or this anconyle process enters into the olecranon fossa. While in extreme flexion, okay, when you flex the elbow joint, okay, when you flex it very well, this the radius here, okay, this is the radius, this portion of the radius enters into the radial fossa or coronoid fossa, which is located on the cranial aspect of the distal portion of the humerus. Okay, now I believe with this, with these few points of mine, you have been able to understand the major points or major parts of uh, the forearm in our domestic animals. Okay, let me remind us again that you see we have dealt with this in my previous video, and then here we have dealt with this, that's the humerus, and then we have also dealt with this. Now it is time to come down to the carpus, the metacarpus, and then the digits. Let's look at them. Okay, the bones are from the carpus, the bones are from the metacarpus, the bones are from the digits, the carpus, metacarpus, and then the digits. Let's start with the carpal bones. Now, typically, this is the distal extremity, okay, of the radius of the forearm. Okay, that's the radius and ulna at this point. So this is the distal extremity. Okay, so after the radius and ulna, okay, that's the upper arm. All right, after there we have the carpal bones. So this is the carpal bones, after which we now have the metacarpal bones down here. These are the metacarpal bones. So let's start with the carpal bones. Let me use a, a drawn image. Okay, that's a schematic diagram. Let's use a schematic diagram to study this clearly so you can get it. Typically, the carpal bones are 8 in number. They are 8 in number, and these 8 bones are grouped into 2 layers. Okay, they are grouped. Let me use this. Typically, they are 8 in number, and they are arranged in 2 layers. Okay, now, so let me take it again. The carpal bones, or the bones that form the carpus, are typically 8 in number. Okay, and they are arranged in 2 layers. Now we have 4 bones in the proximal layer and 4 bones in the distal layer. 1, 2, 3, 4. 1, 2, 3, 4. Clearly. Okay. Now, so these 8 bones, like I said, are arranged in 2 rows. This is the proximal row, and then this is the distal row. Each row has 4 bones. Each row has 4 bones. Now, this is the carpal, the bones of the carpus in the pig, in swine. All right. Let's see how they are named. Okay, let's see how they are named, because they are not just named randomly. Remember that this is the radius and this is the ulna. Okay, this is the medial part of the limb, and this is the lateral part of the limb. This is the part that is closer to the body. That's the medial part. Then this part that is away from the body is the lateral part. Okay, so that means, and then so in naming these bones, or in identifying these bones, we name them from medial portion to the lateral portion. So we go from medial to the lateral. So now this is how the name goes. The first bone in the proximal row is called the radiocarpal bone. The radiocarpal bone. Radiocarpal bone. Then the second bone here is called the intermediate carpal bone. Intermediate carpal bone. Then the third one is called the ulnar carpal bone, while the fourth one is called the accessory carpal bone. These are their spellings here. The first one is a radial carpal bone. Here it's also called the radial carpal bone. Still correct? Okay, radiocarpal bone or radial carpal bone. The second one is called the intermediate carpal bone. Intermediate carpal bone. The third one is called the ulnar carpal bone. Ulnar carpal bone. While the fourth one is called the accessory carpal bone. Accessory carpal bone. Now let's go to the distal row. The distal row is numbered, not named now. It is numbered. Okay, it is identified with numbers from the medial side to the lateral side. So the first one, we have the first carpal bone, which is called carpal 1, this carpal 2, carpal 3, and carpal 4. Take it again: carpal 1, carpal 2, carpal 3, and carpal 4. This is numbered using Arabic numerals. Okay, Arabic numerals. Okay, now having talked about that of the carpal bones of the pig, okay, or swine, let's look at the carpal bones of the, let's look at that of the carnivores now, or the dog. Okay, so in the dog, or in canines, the radiocarpal bone and the intermediate carpal bone are fused here. They are not separate. They are not present as separate bones. unlike what you have here. Here they are fused. Now this fusion gives it the name intermediate radiocarpal bone. Is one word. Intermediate radiocarpal is one word, then bone. So intermediate radiocarpal bone. Then we have a separate ulnar bone, have a separate accessory bone. A separate ulnar carpal bone and separate accessory carpal bone. This one is called intermediate radiocarpal bone. Now the distal row has separate carpal 1, carpal 2, carpal 3, and carpal 4. Let's look at what happens in the equine species. The radiocarpal bone is available, is present, intermediate carpal bone is available, ulnar carpal bone is available, accessory carpal bone is available. Now in the distal row, the first carpal bone, that is a carpal 1, may or may not be present. In some equine species, if you open up, they may be there. In some others, they may not be there. Okay, but carpal 2, carpal 3, and carpal 4 are all present. Let's see what happens in the bovine or ruminants. Now, in this case, the proximal row has all the bones present separately. Now, in the distal row, carpal 1 is not present. It did not develop. It did not develop. But carpal 2 and carpal 3 are fused together to form carpal 2 plus 3. It is a fusion of carpal 2 and 3. So carpal 2 and carpal 3 did not develop as separate bones. They are fused together to form one bone. They will now have separate fourth carpal bone or carpal 4 bone. Okay, I think this is clear now. This is clear. Now let's move to metacarpal bones. I know I'm supposed to start this in the next slide, but because of this diagram here, it will be good for me to start here, to start the explanation here. Okay, now let's start from that of the dog. In carnivores, the metacarpal bones are named from medial to lateral, just like the carpal bones. And these bones are typically made up of 5 bones, not 8 now as in the carpal bones. In this case here, in the metacarpal bones, they are typically made up of 5 bones. 1, 2, 3, 4, 5. So we have metacarpal 1, metacarpal 2, metacarpal 3, metacarpal 4, and metacarpal 5. 5 bones typically. And then these 5 bones are named from the medial part to the lateral part using Roman numerals, not Arabic numerals now as in the case of carpal bones. Here we use Roman numerals in naming from the medial aspect to the lateral aspect. Okay, so here in the dog we have complete 5 metacarpal bones, carpal 1, 2, 3, 4, and 5, fully developed. Now, let's look at what happened in the equine species. In the equine species, carpal 1 and carpal 5 did not develop. So what developed is metacarpal 1 and metacarpal 5 did not develop in the equine species. Okay, what developed in the equine species are metacarpal 2, metacarpal 3, and metacarpal 4. Now, when you look closely, okay, at these metacarpal bones, you find out that metacarpal 3 is more developed, very much more developed. So it is larger than the remaining 2 metacarpal bones, that's metacarpal 2 and metacarpal 4. So this one in the horse that is fully developed and that is more developed is called the cannon bone. The cannon bone, that's metacarpal 3. While the metacarpal 2 and metacarpal 4 are called the splint bones. The splint bones. Splint bones, while the metacarpal 3 is called the cannon bone in the horse. Now, in ruminants, metacarpal 1 and metacarpal 2 did not develop at all. Metacarpal 1 and metacarpal 2 did not develop at all. Metacarpal 5 only developed as a vestige. It's only present as a vestige. It did not fully develop. It's only present as a vestige or a rudiment. Okay, you only find it being attached are these lateral parts of the developed bones. So the fully developed ones are metacarpal 3 and metacarpal 4, which are not even present separately, they are fused. So these two metacarpal bones developed, but they are fused, so you won't find them as separate metacarpal bones in the animal. So you just find in the live animal, you find a central line separating, showing you that this is a fusion between metacarpal 3 and metacarpal 4. Remember that in this species, there is no metacarpal 1 and there is no metacarpal 2, while metacarpal 4 is present as a vestige, but metacarpal 3 and metacarpal 4 are fused. Now let's look at what happens in the pig. Metacarpal 1 did not develop in the pig. So what developed is metacarpal 2, metacarpal 2, metacarpal 3, 4, and 5. And amongst these 4 that are present, metacarpal 3 and metacarpal 4 are the ones that are larger. They are the ones that are larger, and they are larger than the metacarpal 3, they are larger than metacarpal 2 and metacarpal 5. Okay, now let me come back here. Let's come back here. Now, these things I'm saying, when we get to other better pictures, I may not need to dwell on them again. When you look closely in the dog, the metacarpal 1 is smaller than metacarpal 2, 3, 4, and 5. Look at the size. It's smaller. So this one usually carries what we call the accessory digit, because this one does not really touch the ground. Because very soon we'll go into the digits now after the metacarpal bones. Okay, the next thing is the digits. Now, this one that is smaller than the rest, it carries the accessory digit. So it does not carry the functional digit. Okay, so now we will now call this an accessory metacarpal bone. Now, this one, or we'll call this the metacarpal bone that carries accessory digit, while these other 4 are the metacarpal bones that carries the functional digit. When we talk about the functional digit, we mean the digits that really and actually makes contact with the ground when the animal is standing. It makes contact with the ground, with the floor, when the animal is standing. But the accessory digit does not really make contact with the ground. Okay, so the digit that will be attached to this metacarpal 1 does not really touch the ground, but the digit attaching to these 4 other metacarpal bones makes contact with the ground. So metacarpal 2, 3, 4, and 5 in the dog carries the functional digit. Let's come to the horse. Metacarpal 3 and 4 did not fully develop even to the entire, they didn't get to the entire length of the metacarpal 3. Remember I said the metacarpal 3 is the cannon bone. It is the metacarpal 3 that carries the functional digit in the horse. Metacarpal 3 carries the functional digit in the horse, because the digit that touches the ground in the horse, of course the horse has only 1 digit for each limb, okay, and that digit is attached to metacarpal 3. Now, while metacarpal 2 and metacarpal 4 are splint bones, they don't carry any digit. Coming to this, the bovine or ruminant, metacarpal 3 and metacarpal 4, which are fused, carries the functional digit. That's why you see that in ruminant they have 2 digits and 2 hooves for each limb. Metacarpal 4 did not fully develop. It was only present as a vestige, so it did not carry any digit. It doesn't carry any digit. Now, in the swine, metacarpal 3 and metacarpal 4 are larger than metacarpal 2 and metacarpal 4. So these two here, the metacarpal 3 and metacarpal 4 carries the functional digit, while metacarpal 2 and metacarpal 4 carries accessory digits. Let's look at more slides and pictures. So we're rounding off, sliding down to the digits. So this is metacarpus and digits, metacarpal bones and the digits. Okay, this is what we see in man, in humans. Okay, see the 5 metacarpal bones, 1, 2, 3, 4, 5. Okay, so this is assumed to be the functional digit. Okay, why this is assumed to be the accessory digit. Now let's look at this. Let's look at this is what we find in the dog. Okay, This is what we find in the dog. So as you can see, let me do this. As you can see, this is metacarpal 1, this is metacarpal 2, this is metacarpal 3, this is metacarpal 4, this is metacarpal 5. So 1, 2, 3, 4, 5. These are the 5 metacarpal bones. But metacarpal 1 here, carries, in the dog, this metacarpal bone or this digit being attached to this metacarpal bone does not touch the ground really. That is not the bone, that is not the digit, or this digit here, that's not the digit that supports the weight of the dog. It's actually this 1, 2, 3, 4 that does the major job of holding the weight or carrying the weight of the dog. So we call this an accessory digit, while these are the functional digits. So the metacarpal bones that carries the functional digits are 1, 2, 3, and 4 metacarpal bones. Okay. Now this is let's look at this case here. Okay, this is what we see in the pig. Okay, in the pig. Remember that the first metacarpal bone is not present in the pig. Metacarpal 2, 3, 4, and 5 are present, while metacarpal 3 and 4 carries the functional digit. See how large it is. These are the two that really touches the ground, okay, and carries and bears the weight of the animal. So these two are called the functional metacarpal bones. These two here, this one here, and this one here. Okay. So these ones carries the functional digits, while this and this carries the accessory digits. So these are the accessory digits, while these two, that is metacarpal 3 and 4, carries the functional digit. Let's look at what happens in the horse. Sorry, in ruminants. This is ruminants. Okay, you see the fusion. Metacarpal 3 and 4 are fused to form a single metacarpal bone. Okay, but they carry the functional digits. Okay, these are the functional digits. Now this is what happens in the dawn horse. Okay, the dawn horse, which is believed to okay, so the dawn horse is believed by scientists to be the very first horse that ever existed. The very first horse that ever existed, but it is extinct now. Okay, and it has photos. So let's leave this, okay? But I believe you can get an explanation for this, using this picture. So let's see what happens in the horse that we know. Okay, this is the horse now. Remember that the metacarpal bone in the horse is made up of 3 bones: metacarpal 2, 3, and 4. Okay, now metacarpal 3 is the cannon bone, while metacarpal 2 and 4 are the splint bones. Okay, so metacarpal 3, which is known as the cannon bone, carries the functional digit in the horse. Okay, so this is clear. Horse, okay, just like I said earlier on, the dawn horse. Okay, this is a metacarpal bone in the dog. Okay, and then the digits. So let's talk about the relationship between the metacarpal bones and the digits now. Okay, let's start with the horse. And here I'll be mentioning some additional structures, but I'll be dwelling more on the digits. Typically, each digit is made up of 3 bones. 1, 2, 3. So this is the digit, this is another digit, this is another digit, this is another digit, and this is another digit. Okay, so the metacarpal bones here are this: metacarpal 1, metacarpal 2, 3, 4, and 5. So the digits are attached to the metacarpal bones. So let's color the metacarpal bones. this, 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 this. Okay, so now since we know that this is metacarpal 1, metacarpal 2, metacarpal 3, metacarpal 4, metacarpal 5 in the dog, then these are the digits. So like I said, each digit is typically made up of 3 phalanges: phalanx 1, phalanx 2, and phalanx 3, or you call it proximal phalanx, middle phalanx, and distal phalanx. Proximal phalanx, middle phalanx, and distal phalanx, or you say phalanx 1, phalanx 2, and phalanx 3. Phalanx, the digits 2, 3, 4, and 5 in the dog are all made up of 3 different phalanges. Digits 2, digits 3, digit 4, digit 5 are all made up of proximal, middle, and distal phalanges. But the digit 1 is, we only see 2 phalanges, the proximal and the distal. And the proximal phalanx in the dog is believed to be a fusion of phalanx 1 and 2. That is a fusion of proximal and middle phalanx, fusing to form only this proximal phalanx. And then we'll have the distal phalanx. Now, on the dorsal aspect of the digit, or between the metacarpal bones, between the metacarpal bones and the digits in the dog, on the dorsal aspect, we have single sesamoid bone. That is this bone here, this round bone. So each of, at the junction, or okay, the junction between the metacarpal bone and the digit is called the metacarpophalangeal joint. Of course, this is the first phalanx, so it's called metacarpophalangeal joint. This is also metacarpophalangeal joint between the metacarpus and phalanx. Metacarpophalangeal joint, metacarpophalangeal joint, metacarpophalangeal joint. So each of these joints bears single sesamoid bones. Now, what are the functions of these sesamoid bones? The sesamoid bones, you see here, they protect tendons from excessive wear. Okay, they protect the tendons that are around this joint from excessive wear. They also reduce friction. Okay, they reduce friction and increase mechanical advantage for muscles. Okay, they act as pulleys. Okay, and then to enhancing muscle force generation. Okay, so they are very important and in supporting weight bearing. Okay, so they are very, very important in protecting tendons and from excessive wear. Okay, and also reducing friction. Okay, so on this dorsal aspect of the paw, that is the dorsal aspect of the metacarpophalangeal joints, we have a single sesamoid bones on each of the digits. Okay, on that particular part of the joint. Now let's look at the palmar surface. Since we have looked at the dorsal surface, let's look at the palmar surface. That's the inner surface of the digits of the joint between the metacarpal bones and the digits of phalanx. So this is the volar aspect. Okay. Now on this part, if you look at the metacarpophalangeal joint, you have 2 sesamoid bones each, 2 on the functional digits. Okay, between the metacarpal bones and the functional digits, you have 2 sesamoid bones each. Then on the metacarpal 1 and the accessory digit, you have 1 sesamoid bone. Okay, so here now we have 2 plus 2 plus 2 plus 2 plus 1. We have 9 sesamoid bones on the volar aspect. That is on the palmar surface of the metacarpophalangeal joint in the dog. 9 sesamoid bones. Okay, 4 pairs and a single sesamoid bone. While on the dorsal aspect, just like we saw in the previous slide, there are only 5. Okay, one being present on each of the metacarpophalangeal joints. But on this palmar surface, we have two being present on each of the functional the functional portions and one on the accessory portion. Okay. Now let's look at what happens in. Of course, there are no other sesamoid bones present in the rest of the digits here, in the rest of the joints of the digits of the phalanges, as we can see here in the dog. Now let's look at what happens in the pig or porcine. Now, on the dorsal aspect, okay, we saw earlier on that there are the bones here. You see these two now carrying the functional digits. So these two digits are the ones that make contact with the ground. Okay, so they're the largest. They're the largest sesame. They're the largest. So metacarpal 3 and 4 are actually the largest. Metacarpal 3 and 4 are actually the largest, okay, in the largest metacarpal bones in the pig. Of course, the metacarpal 1 did not develop, so we have metacarpal 2, metacarpal 3, metacarpal 4, and metacarpal 5. So metacarpal 3 and metacarpal 4 are the two metacarpal bones that carries the functional digits, and these functional digits are the digits that make contact with the ground. You see metacarpal 2 and metacarpal 5 are carrying accessory digits. Accessory digits in the sense that they don't really make contact with the ground. They're almost floating. Okay. Now let's look at their metacarpophalangeal joint. Okay. When we look at the dorsal aspect, okay, this is the dorsal aspect. Okay, while this is the ventral part, that is the palmar surface of the manus of this portion. Okay, when you look at this dorsal aspect, you find out that there are no sesamoid bones present on the dorsal aspect of the metacarpophalangeal joints. There are no sesamoid bones present. See, there are no sesamoid bones present here. Okay. Now, when you look at the ventral aspect, that is the palmar surface, you find out that there are two sesamoid bones present on each of the metacarpophalangeal joints. There are two here, there are two here, there are two here, there are two here, making it eight sesamoid bones present on the palmar surface of the metacarpophalangeal joints in the pig. Okay, now additionally in the pig still, on the distal aspect, so let me take this again before I come down to this point. The metacarpophalangeal joint on the palmar surface in the pig has two sesamoid bones each, making it a total of 8 sesamoid bones at that point, at that position. Now, when we look at let me say this here, that there are joints present on the digits between the phalanges, and these joints are, let me use this, okay, we have the metacarpophalangeal joint here between the metacarpal bone and the first phalanx. Then we have proximal phalangeal joint, and here we have the distal phalangeal joint. You can either call it phalangeal joint or interphalangeal joint. This is a proximal, and this is a distal. This is proximal, this is distal. This is proximal, this is distal. This is proximal, this is distal. Okay, distal interphalangeal joint, proximal interphalangeal joint. Okay, so let's come back here. Having talked about the metacarpophalangeal joints, now let's look at the distal interphalangeal joint. Now, if you look at the distal interphalangeal joint here, in this digit, accessory digit, there is no sesamoid bone. Look at this one here, there is no sesamoid bone. But when you look at that of the digits, that is the third and fourth digits, okay, the third and fourth digits. Now, this digit 2, 3, 4, and 5. So this the distal interphalangeal joint of the third and the fourth digit have one sesamoid bones each on this same palmar surface. So the total sesamoid bones present on the palmar surface of the manus in the pig are 10. 2, 4, 6, 8, 10. 8 here and then 2 here. Let's look at the case of the bovine species. In the bovine species, we have, let's start from the dorsal surface. This is the dorsal surface here. This is the dorsal surface here. So there are no sesamoid bones on the dorsal surface. But on the ventral surface of the bovine species, of the manus of the bovine species, at the metacarpophalangeal joints, you have 2 sesamoid bones each. 2 here in this digit, 2 here in the second digit. That is 4 altogether. Now, when you come to the distal interphalangeal joints, there are 1 sesamoid bone each on each of the digits. So each digit has a total of 3 here and 3 here on their palmar surfaces, making it a total of 6 sesamoid bones on the palmar surface. There is no sesamoid bone on the dorsal surface of the manus in the bovine. Remember that manus is made up of the metacarpal bones, the carpal bones, metacarpal bones, and the digits. Okay. Now, finally, let's look at what happened in the equine species. There are no sesamoid bones present on the dorsal parts. Okay, this is the dorsal part. There are no sesamoid bones present there. Okay, but on the ventral surface, we have 2 sesamoid bones present on the metacarpophalangeal joints. 2. You know, it's just 1 digit in the horse. Okay, which is borne by metacarpal 3. That is a cannon bone. There are 2 here and 1 here. Okay, let's look at it. Let's use this now. On the ventral surface or palmar surface, we have 2 sesamoid bones between the at the metacarpophalangeal joint. That's between the metacarpal 3 and the first phalanx in the horse. These are the 2 sesamoid bones. Now, on the distal interphalangeal joints, we have 1 sesamoid bone. This sesamoid bone is also called the navicular bone. The navicular bone in the horse. Navicular bone in the horse. So there's a total of 3 sesamoid bones on the digits in the horse. Okay, in just 1 limb. Okay, so remember that this is metacarpal bone. That's a cannon bone. Okay, and then these are the phalanges that make up the single digits in the horse. Finally, we already know that the digits in our domestic animals or in our animals are named as follows: digit 1, digit 2, and digit 3. Okay, digit 1, digit 2, and digit 3. Sorry. Phalanx 1, phalanx 2, and phalanx 3. I take it again. Each digit has 3 phalanges. Phalanx 1, phalanx 2, and phalanx 3. Or you call it proximal phalanx, middle phalanx, and distal phalanx. But in the horse, in the equine species, we have specific names for these phalanges. Okay. Now, these names are, this first phalanx or proximal phalanx is called the fetlock. Fetlock. Okay, it's called the fetlock. The fetlock. This second or intermediate phalanx is called the pastern. Pastern. While this third phalanx or distal phalanx is called the coffin bone. The coffin bone. It is this coffin bone that is enclosed by the hoof. It's a coffin bone that is enclosed by the hoof. Thank you very much for your time and for listening and also reading. I want to believe that this video, these lectures have helped you. If you have questions, please drop them in the comment section. Thank you once again. This is Dr. Fred Academy.